reflection or rotation? Can you tell the difference? One of the more interesting challenges when it comes to rigid transformations is taking a look at a picture like this, or this, or this, or this, and determining whether you're looking at a reflection of the preimage or a 180-degree rotation of the preimage. After all, they look almost identical to the untrained eye. They both look like the opposite or the upside down version of the original preimage. So, before we begin, can you tell which of these are reflections and which of these are 180-degree rotations? Give it a try. Pause the video and let me know which you think are which. Got them all? Let's see. Number 1, reflection or rotation. This is a 180-degree rotation with a center of rotation right about here. Number 2 is a reflection with a line of reflection down the middle. Number 3 is a 180-degree rotation with a center of rotation in between. And number 4 is a reflection with a center of rotation, with a line of reflection in between the two shapes. So, did you get them all right? If you did, how did you know? If you didn't, is there anything that you can spot now that helps you? If not, there are some more formulaic ways in which we can go about figuring out whether we're dealing with a reflection or a 180-degree rotation. So if you're unsure, give one of these methods a try that I'm going to demonstrate. First of all, reflection. The big thing about reflection that you're going to be able to use is the fact that it's got parallel alignment. What that means is that corresponding points are opposite each other in a parallel fashion. That means if you were to draw an imaginary line between each pair of corresponding points, they would all be heading the same direction in parallel. Another key feature is that corresponding points reverse their rotational order. So if ABC is going clockwise on the preimage, it's going to go counterclockwise on the reflected image. Let me demonstrate. Let's take these two triangles here. I've already labeled A, B, and C on them. Let's draw imaginary lines between the corresponding points. And you can clearly see that these lines are going parallel to each other. They're all going straight horizontal from A to A prime, from B to B prime, and from C to C prime. Furthermore, if we're talking about the rotation of the order, ABC is going counterclockwise, whereas A prime, B prime, C prime is going clockwise. Reverses the order. Now, I'm not going to go into labeling coordinates much in this video. I already did that in a different video. But just to remind you, what if you don't have labels on your points already? Well, you can put labels on your points. You should be able to train your eye to see where corresponding points exist. For instance, if I'm looking at these two trapezoids, I could call the point at the end of the trapezoid A and A prime, and then I could go down the longest length in order to find B, go down the longest length to find B prime, and from then I'm just off to the races. I can just go around to get C and D for each. Once I have my points labeled, then I can conduct my tests. A to A prime, D to D prime, C to C prime, and B to B prime. Once again, as you can see, a parallel orientation for all those invisible lines. And then if we're talking about the rotation, A, B, C, D, we're going clockwise with that, but we're going counterclockwise with the copy. Once again over here, A's line up, C's line up, B's line up, D's line up. They're all going the same direction. There is reflections in all three of these. So how's a rotation going to look different? Well, as opposed to the reflection where there's parallel alignment, with a 180-degree rotation, you're going to have a central alignment. The corresponding points opposite each other are going to be going through a single central point that's shared between all of them. The corresponding points are also going to maintain their rotational order instead of reversing it. And the final bit, which helped me to draw all these 180-degree rotations, is the fact that corresponding sides are parallel to each other. So let's see what these look like in action with our triangles. I've already labeled my A's, B's, and C's. If I draw imaginary lines connecting A, B, and C, well, we already can tell, first of all, that they're definitely not parallel to each other. They're all crisscrossing through the middle. And second of all, they're all crisscrossing at about one centralized point. I'm not the perfect drawer, otherwise they would be going through the exact same point in the center, which, by the way, just happens to be the center of rotation for the transformation. Once again, we can practice getting our getting our points labeled. So we could start here with A, and we could make the long end B. Over here, doing the same thing, A prime and B prime, and then we can work our way around to get C and D for both. Then if we're connecting the dots, A goes all the way to A prime, way over there. B crosses over to B prime, C to C prime, and D to D prime. And there's our center of rotation in the middle between the two. Last but not least, once again, A to A prime, B to B prime, C to C prime, D to D prime, and E to E prime, all going through that central location. One last little mention about the parallel to each other's sides. I just want to show that off. Let's take B to C, for example, on our triangle here, and B prime to C prime on the other triangle. You can see pretty clearly that they are parallel to each other. Same goes for AC and A prime C prime, and of course, the other two as well. And this goes the same for all the shapes. You can point out that this is parallel to this. Each pair of corresponding sides are parallel to their partner. All right, now you try. Here are 6 example problems. The points are already labeled, so this shouldn't be too hard. I would like you to determine which of these 6 are 180-degree rotations and which are reflections. Pause the video, give it a try, and then play the video for the reveal. Number 1. That's a rotation. If we are connecting points, it becomes clear pretty quick that they are not going the same direction. They are all crisscrossing and passing through the same point. Number 2, reflection. We have that nice parallel lines going on there. We have a diagonal line of reflection. By the way, the line of reflection is always going to be perpendicular to those invisible lines, those invisible parallel lines. Number 3, that's a rotation. 1, 2, 3. There's our center. Number 4, reflection. we've got 1, 2, 3, and 4. They're all going the same side, the same direction. And we once again have that diagonal line of reflection. Number 5, this one's a little tough, but if you look at the letters, it becomes pretty clear. G is going to G prime, F is going to F prime, E is going to E prime. They are not going the same direction, they are crisscrossing, so we have a rotation. And finally, number 6, once again, another rotation. S to S, T to T, U to U, and V to V, going right through that central point.